Welcome back to Dr. Liu's VCE Physics. Today's topic is magnetic field, as presented in the 2024 VCE Physics exam. Let's learn together. If teachers, parents, or students notice mistakes in my explanations, please provide me with your feedback. Point X is located exactly halfway between the two south poles. Because the field lines repel and the distance to each pole is equal, the magnetic field at point X is zero. The force on section PQ will be identical in both cases because the current flows in the same direction. In both scenarios, this force acts downwards. However, the resulting torque differs significantly. In diagram A, the force is perpendicular to the loop, creating maximal torque, while in diagram B, the force is parallel to the loop, resulting in no torque. The magnetic force on a current-carrying wire within a uniform magnetic field is calculated by multiplying the magnetic field strength, the current, and the length of the wire. An electron, accelerated from rest by an electric field, subsequently enters a constant magnetic field, where it follows a circular path. Given the magnetic field strength and the measured radius of this circular path, we can rearrange the relevant equation to calculate the speed of the electron. The electron's mass and charge should be obtained from a data book. A common error to avoid is incorrectly converting the radius to meters. If we assume a complete conversion of electrical energy into kinetic energy and neglect relativistic effects, the accelerating voltage between the plates can be calculated by solving the combined energy equation. While an electron and proton share the same charge magnitude, the proton is positively charged and much more massive. In this experiment, replacing electrons with protons would cause an anticlockwise deflection due to their positive charge. Furthermore, their significantly larger mass would result in a path with a greater radius. Students constructed a simple DC electric motor with a single coil of wire in a uniform magnetic field. The coil started at rest in a horizontal position. Since side FG is parallel to the magnetic field, the magnetic force on this segment is zero. If the coil is positioned vertically, the forces on sides EF and GH will also be vertical. This lack of a horizontal force component means the coil cannot start rotating. With the battery and coil kept constant, increasing the strength of the magnetic field is a method to boost the torque. Accounting for 14 of the total 120 assessment marks, 11.7% of the assessment, the magnetic field section consists of 3 multiple-choice questions worth 3 marks and 2 short-answer questions worth 11 marks. If you need my help, you can add me on WeChat or WhatsApp, or send me an email. Thanks for your attention. Please note Dr. Liu's VCE Physics channel, Dr. Liu's VCE Chemistry channel, and Dr. Liu's VCE Biology channel.